Okay, so we're looking for the number of people who waited 20 minutes or less. So what we're going to do is we're not going to go to 20 minutes on this side, that would be wrong. We're going to go to 20 minutes along the bottom and look to see how many people that goes with. So we go up to the graph and along, and that matches with 28 people. For the next question, we're looking for between 26 and 40 minutes. So we're going to find 26 here and 40 minutes here. Now 26 minutes, if you go up to your graph and along, it might be best to use a ruler, you get 42. If you do 40 minutes, go up and along, you get to here, which is 68. So the bit that's between them is going to be 68. Take away 42, which is 26 people. Final thing, it says the hospital has a target and we need to see if it's achieved its target for the day. So they want to know if no more than 15% of people are kept waiting for 40 minutes or more. So 15% of the 80 people they asked is, well, 10% is 8, so 5% is 4, so that's 12 people. So we want to make sure that no more than 12 people, so 15% is 12 people. We're going to look at the data and see what the hospital achieved. So we want to see 40 minutes or more. So 40 minutes we know got us 68, but it's 68 people who waited less than 4 minutes. The people who waited more are this bit here, which is 12 people exactly. 12 people waited more, waited 40 minutes or more. So they achieved their target exactly. I'm looking at question 12 and straight away I think it's a trig question because I've got an angle and a side, and I'm presuming they're going to ask me something about these two sides, but let's read it and check. So we've got a pole ACD, AB is the horizontal ground and BC is a wire. The height of the pole is 9 metres, so up to here is 9 metres. For the pole to be correctly installed, the length DC has to be at least 1 metre. So we want this distance here to be 1 metre or more. 1 metre to be the smallest. Show that the pole has been correctly installed. Well, if it's correctly installed, this will be 8 metres or less. So we need to know whether this length is 8 metres. So this is the one I want to work out, so I'm going to put an X on it. And it is trig. What I like to do is draw a separate triangle. This is X, there's my right angle, there is 68 degrees, there's 8.5, and then I'm working with a simple shape instead of a messy diagram. So, opposite, hypotenuse, adjacent, cross out the one you don't need, you're left with O and H, write out so, ka, toa, or however you remember it, cross out both the ones that have an A in, because I've crossed out A, I'm left with sin. I'm going to write out my triangle, and I'm going to replace it with the values I know. Sin goes with the angle, and I know the hypotenuse is 8.5. I don't know the opposite, that's what I want to figure out. I know the bottom two, so I'm going to multiply. I'm going to type in my calculator, sin 68 times 8.5. So sin 68 times 8.5, which is minus, it would help if I close my brackets. It's one thing to note, if you just type in sin 68 and times, it brings up just that without a bracket on. You have to make sure you go back and put the bracket in to close it, otherwise you're going to get it wrong like I just did. So sin 68 times 8.5 like that. And that is 7.881. Now, that's got us where we needed, but it's not answered their question. They asked us whether the pole had been correctly installed. It's less than that 8 metres, so it has been correctly installed. Make sure you finish off with a sentence to stop because it's got a star on it. Question 13 is a proportion question. I like to write the initial sentence in a proportion question down as an equation straight away. So the time t in seconds, so t, is proportional to the square root of the surface area. The square root of the surface area. And I can rewrite that and replace the fishy thing, as my year 11s last year used to like to call it, with equals k. Because this is how we change, using a constant called k, we change that into an equation, root a. So we're going to put in the two values I know. I know that when t is 40, a is 100. So when a is 100, k times the square root of 100 is 40. I know the square root of 100 is 10. So that means that this k has to be worth 4, otherwise the equation won't work. So I can change this rule into being t equals 4 times root a. I can now work out what they wanted me to. They've asked me find the value of t when a is 60. So I know that what I need to do is 4 times the square root of 60. And I can do that on a calculator because obviously the square root of 60 is not a nice one. So 4 times the square root of 60, which is 30.9838667. Notice I'm writing down everything first, so that when I do my rounding to 3 significant figures, I don't lose too many marks. So 30 point, well, careful, because if I round to 3 significant figures, the 9 becomes a 10, so actually it's 31.0.